A workshop makes a cupboard using two artisans, A and B. Every cupboard requires 3 days of work. So let us just use direct inequality formation as we continue. So we have 3 days required for artisan A and 2 days for artisan B. So the total number of days should be less than 24. So we have to say that 3x, because they are saying the value of cupboard workshop to be x of cupboard and y for the table. So 3x plus 2y should be less than 24. The next one we can say that we got told that 2 and 2 days of artisan. So we stopped from here. Every table made requires 2 days of working by artisan A and 2 days of working by artisan B. So both of them, they need 2 days. So we'll say that 2x plus 2y, this one the total number of days. Let us see. Part B should be more than 18. So you can, however, simplify this, still no problem. Then write down all the inequalities. We have also an inequality of x is greater than 0 automatically because there are more than 1. Also y is greater than 0. So these are just a few of the inequalities that we can get from that point. Then now it's time for solving. To solve, we are going to say, just substituting here a point, let me have it done here. So 3x plus 2y here. If we take the values of x and y to be 0, 0 on each case. If I substitute 0 here, so it means I'm going to divide y by 2, which means that y is 12. If I substitute 0 in y, it will be 0, so divide here by 3, that is 8. So we have 0, 12, 0, 12, and 8, 0. So that is the first equation. Then also the next one, we can use the xy, 0, 0. If I put here 0, I'm going to divide the y by 2, so y will be 9. If I put here 0, also it will be 9. So 0, 9, and 9, 0. Then I'm now going to join them. So this is how the drawing is supposed to be, and also the shading. So this side should be for the x is greater than 0, and this side should be y is greater than 0. Then the other ones we have done them. So you are told to use the cupboard. The shopkeeper makes a profit of 6,000 on each cupboard and 4,000 on each table. Find the number of cupboards and the number of tables that must be made to a maximum profit, and hence determine the maximum profit. So to work on that, we are going to look at the objective function. There we can say, because 6,000 is for x plus 4,000, which is for y, should be equal to the profit. So I can decide to draw this. If I simplify this, I can write it out this way, and the profit, which I don't know, if I add this and this, it is. So I'm going to look at the table. So using my table, I can decide to use the search line method, where I will look at a point that can give me a maximum profit, and I can take at that point. You check every point. You see this is 9, 9. So because this one is not touching, we can use this point, 5, 4. So we just say that x is equals to 5 and y is equals to 4. So the profit therefore will be 6,000 times 5 plus 4,000 times 4, giving me a maximum profit of 46,000.